Hey guys, welcome back to my channel. Today we're going to be solving the qualification round of 2019, the IAAC qualification round. So we have problem A, planet stars. So the Earth has a distance of 1 light minutes to our sun. So it's 8.3 because it takes 8.3 minutes for light from the sun to reach Earth. Question number 2. When the moon covers the sun, we call it solar eclipse. There are 8 planets and Jupiter is the heaviest of them all. The smallest planet is Mercury. I think 88 days. The brightest star is Sirius. And it's just about one of about 100 billion stars in our Milky Way. The galaxy is the closest by that's Andromeda. Andromeda. I'm pretty sure it's also visible in the night sky. Sometimes with the phone, I think, as well. Okay. So how many Earths fit into Jupiter? So to calculate this, we'll have to take for the volume, we'll take the radius, a ratio of the radius, so it will be 7,000 by 6,371, and this will be cubed. And for the density, I'm pretty sure since so what we'll do is multiply the average densities by this to work out the mass. Okay, so this will just be let me put this into my calculator. So I'm getting an answer of 1.3. Oh no, wait, it's not that. I accidentally put 7,000. It's kilometers, so it will have to be in meters. No, wait, what? Oh yeah, this is 70,000. Yeah, okay, that's my mistake. Yeah. 70,000, so yeah, 1,326. Yeah, that's so 1,326 Earths fit Jupiter. Okay. So we worked out the radius of the planet, the ratio of the radiuses that should give us the by volume. Now for how much heavier we have to use density. So the density of Earth, so the density of Jupiter 1326 by 5.514 into this that we just calculated. Oh, what? Oh, this is the same number. That's okay. Okay. Yeah. to the density of this by the density of this into this, because that's how many words fit in it, will give us the solution. So I'll just put that in my calculator. 1326 by 5.514. Oh, actually, wait. Since this is in kg and this is in grams, we can multiply this by 1,000. So we get 5514. So we get it in kilograms. So 5514 will be 1326 kg per centimeters cubed. Oh wait, it's in meters cubed as well. Wait, I should have probably removed this here. We keep it like this. I'll just read this question. Okay. Okay. So we need this in this form. So we can just multiply it to get here. Okay, it was the same thing. 1326 into 1326 is equal to approximately 318 times heavier. Okay, so this is problem B done. Now problem C. Okay, so the distance is this. We have a speed and we have acceleration for Bob. So let's write down here Bob is equal to 1.4 kilometers per hour squared, and then Alice has kilometers per hour, not squared because it's speed. So acceleration and 500 kmph. Okay, so start slowly but constant acceleration. Okay, we have a common distance is equal to 3,840. Is that it? Oh, 3 zeros, kilometers. Okay, so for Alice we can calculate the time taken because speed equals distance by time. That's super easy to do. We can say 500 is equal to 3,840 384,000 by t, which we can just substitute out here 500. So we can say that after rearranging, t is equal to 500. So these two cancel out and we're left with 3840 is equal, divide by 5, which is 768. Okay, 768 hours it will take Alice. Okay, so we have done Alice. Now we need to find Bob's. 768 hours. So for this, we can use another Subat equation, which is S is equal to 1 by 2 AT squared. Okay, I'm pretty sure the divide from V squared minus U squared is equal to 2AS, because V minus U by T is equal to A, and then stuff like that. Yeah, so I think it's derived that way. So for this, since we don't have time, we have the acceleration and distance, so it will be, since it's 1.4, so 0.7, so 384 384,000 by zero point 0.7 t squared. So this will be 84.7, 384,000, so 548, and then square root of that, so around 744 hours. So t is equal to, it's like approximately 741 hours, let's say, because it's 740.656, so it's 741 hours. So who wins the space race? Bob will win, reach 8 hours earlier. Keep in mind, it says to write down your steps. I have written for Bob, but I ran out of space, so you have to do that. Okay, space collide. The forces from Earth and Moon cancel out. The gravitational force on the spaceship is given by this equation with the constant of g. I'm pretty sure this is equal to 6.67 into 10 to the power minus 11, I think. Let me just Google it because I'm not really sure. Just to be sure, because I think constant value. Okay, it's I was right. It's 6.674 though. 6.674 into 10 to the power minus 11. That's the value of g. It's a constant. Yeah. It's a much larger value, but I think we'll use that. I think we'll just stick at 6.67, honestly. Yeah, so this is the value of g. So now to solve this, what we'll do, since this is resultant force, and at the Lagrange point, the Earth and the Moon cancel out, so this will equal to 0. And the mass of the spaceship, is it given somewhere? Is it given here? No. What? You don't have the mass of the spaceship. Okay, we just have 6.67. That's it. The distance of r, it is actually kind of difficult. So because this is equal to 0, we can just say what? Okay, I'll come back to this question. This one's actually very tricky. Yeah. Okay, so polar lights. Since fascinated by natural phenomena, polar light, symbol of beauty. Today we understand the scientific reason. Explain the scientific causes. Okay. So I'm pretty sure by now everybody knows it's caused by the radiation, or not radiation, more like solar wind. A solar wind that collides with the Earth's magnetic field. I'm pretty sure everybody knows that since the magnetic fields are declining and it's all wind over Earth. Okay, so solar winds that collide with the Earth's surface, with the Earth's magnetic field. Okay, so then the particles. This is the part where most know. This is the reason this happens, and this is the what actually happens. So the particles, like the solar wind particles, so what happens is the particles go through I don't know how to explain it clearly, but like the Earth's magnetic field puts them through an area where they're like in the upper atmosphere, so now they can what do you say hit, I would say, or collide with the oxygen and nitrogen atoms that are there. Oh wow. Okay, so the particles are sent to the upper atmosphere and to the upper atmosphere they can where I probably shouldn't zoom in this much, where they can collide with oxygen, with like the gases in the air. So since oxygen and nitrogen are most present, I'll just write that are 21% and nitrogen. Or what? Okay, so of course when they collide they gain energy, I would say. So which so basically when they collide they get excited and they release light in the form so that they can turn. So basically when they collide they gain energy. Yeah, so after gaining energy they start glowing, so as a form of releasing the energy. Okay, so the collision excites and which emits light. They emit light. Okay, so this is what the emission of light produces the auroras. Aurora? Yeah, it's auroras. Auroras or polar lights. Polar lights. And also I'm pretty sure after this if it's in oxygen, I think it produces the green lights, and in nitrogen it produces red lights, I think. Oxygen green and nitrogen red. I'm not sure about this one. This I just remember at the top of my head. So yeah. Okay, so now let's go back to this. This one's really complicated. Should I just leave this out? I guess I'll attempt it. And I can still qualify because... is there no qualification? Okay, so usually there's an age qualification. I'm pretty sure just leaving out one problem won't affect it that much, but you can still try to gain like 1 or 2 or 3 or 4 extra marks. This could help you qualify. So I would say don't leave it blank because you have a lot of time to solve it. Maybe one day you're just looking at it and the solution might click. Okay, that calculates the distance. So distance, I'm pretty sure is d, right? That's anywhere the distance is d, and it has to be, right? Oh yeah, d is the distance. Okay, so I'm pretty sure we just have to rearrange for d in this. Because how else are we supposed to solve this? Okay, so this is 0, and m, mass of the spaceship, and the mass is me, m of moon, and the distance between Earth. The distance of spacecraft to the center of the Earth. Okay, so we have the distance to the angular point. Okay, so we don't have to calculate d, we have to calculate r, I'm pretty sure. Okay, distance to spacecraft to the center of the Earth. Okay, so this is what we're calculating. The r is what we have to calculate. Okay, so let's go inside the bracket because f of r is 0, and this we can just solve. We can just multiply everything later. So m g, and then m e. Wait, we don't even need this. Since we're calculating for distance, we can just solve inside the bracket. What? I don't know what to do here. Honestly. Okay, wait, B is just a lot easier, so I'll just answer B. So, for B, the solutions are, first of all, it says missing aspects in the calculation due to the assumption that Earth and Moon stay there. So it says Earth and Moon, so we're not acting for the like other planets and Sun. Okay. Also, planets and the Sun. Okay. What else? Oh wait, okay, wait. Okay, wait, it's this, and I'm pretty sure we can say that it says the system, they stay at rest. So like what they're not accounting for is like when they move, they'll have different they'll have different L points then. This is only one of them. So like if the Earth is here, the Moon is here, like you can say the L point here. But if the Earth is like rotated, not the Earth, if the Moon is here, then the L point here, the L point won't be here anymore. So okay, yeah. So like there could be different L points depending on the position of Okay, so now for A, I'm pretty sure like I'm pretty sure there are 5 marks. Yeah, it's 5 points. This I'm pretty sure is then 2. This is 3. Okay. Can I insert a blank page? No. Okay, I don't think I can insert a blank page. Okay, wait, I can. Okay. So, problem D, I think. Is it problem D? Yeah. Part A. Okay. So, yeah, problem D. ME by ME by R squared MM by DR minus. Wait, what? ME by R squared oh no, not equal to subtraction. MMDR squared. MMDR squared. Is it minus? Yeah, D minus R squared. A whole square? Yeah, it's whole square. Okay. So what I can do is easily calculate this. So MER squared minus D squared minus 2DR plus R squared. Okay. So since there's R squared already here, we just have to multiply both sides by this. Which means R squared plus D minus 2DR. Yeah, like this. This isn't plus though. This is just R squared, so if we multiply it then it won't stay the same. I think we just do this. D squared minus 2DR plus R squared is, this will be MER squared. This cannot be the correct way. What? Oh no, not MRC. This will be like ME minus 2DR minus 2DR. What am I doing? Plus R squared and no, it's minus. What am I doing? R squared, I guess. Okay, this does not make any sense. What? Okay, I have no clue. Okay, so I don't know how to solve this question. Okay, now let's look at the solutions of this, since I'm finished. Like everything except problem D I was able to do. So now let's see, check my solutions, and yeah. Okay, so we have the solutions over here. Let me just change my pen color to red. Okay. Okay, so we have solutions over here. So it's 8.3, but it says approximately 8. So I think this is fine. Then solar eclipse, Jupiter, Mercury, 8, yeah, Sirius, 200 plus or minus 150. What does that mean? Is it saying that it's in, it's in between, okay. No, so 200, it's in between 200 and 50,000. What, last time I said, okay. And this is Andromeda. Yeah, this is a disappointment, bro. What? Okay, so this is 5 points, so I'm pretty sure I would get 4 out of 5. The size of Jupiter, 326, nice. And 390, okay, it's the same thing, I just rounded differently, so it's correct. This calculation would be the same result, irregardless. Okay. Let's, see, 741, okay, and 768, so 5 points. Yeah. Okay, fine. I won't give myself the mark for this, but I did this right, so I will get 4 out of 5 again, just because I didn't round it up correctly. Be a bit harsh on myself, because when the real exams comes, of course they won't do it this. Where's the back button? What? Okay, 318, wrong, 319. Okay. Yep, 5 points. And now this question. Angular velocity causes additional L points here. Okay. More. Okay. So planets and the sun, it's not given, but I think that would also be one. Now this question. What have they done here? FR1 is equal to 0. R1 is equal to... How do you get this? What? There's nothing given. Okay. Oh, what the... Where's the undo button? What? Okay. I have no clue what they did here, but like I can try and get a solution. The charged particles interacting with the Earth's magnetic field, that's what I said. Flow to ionization and excitement atoms in the atmosphere. Oxygen, yellow. Oh, okay, it's blue. Okay. So I got this right, but I won't get the nitrogen. What does the reg mean? Is it red? Is that correct then? Wait. REG color. Is REG a color? Did I get this right? I mean, I said oxygen is green, nitrogen is red. I think they meant... Is this a typo? I'll say no, because it says violet and blue. So again, I would get 4 out of 5 points. Okay, so where did I lose? So 4, 8, 13. I'll probably get 3 marks in this. 13, 16, and then 20. So 20 out of 5. I think it's out of 25. Problem A, B, C, D is 4. And then there's a problem E as well, so 5. 25, okay. 20 out of 25. I mean, okay, some mistakes could have been avoided, like especially this rounding one. This is like, okay. And this one. Okay, so kind of like got mixed up between something, I guess. And yeah, so this is for today. I got, what was this? Okay, so I got 20 out of 25, which as a percentage is about 80%. What? Okay, 80%, but remember it does not... Okay, yeah. Why can't I move this? Okay, at least 15 points for... What? Okay, 20 points and I got that. So I did qualify for the pre final round, and since I'm in junior, I'm under 18. So I got 15. I got way more than 15 points. So I did qualify. And even if I was over 18, I would have qualified because it's 20 points. So yeah. So I did qualify for the pre-final round, and we'll do that next video. Thank you everybody for watching, and I'll see you in the next